Hi, Algebra 1 kids. This is Dr. Callahan for week 2, Monday. Congratulations on finishing the first week. I hope you guys had a great weekend. So go ahead and pause the video and answer the following 3 questions. Okay, we're going to go ahead and create the assignment for today. So this is going to be for week 2, Monday. And so this is week 2, Monday, Algebra 1, semester 2. And today we're going to talk about exponential, decay, and growth. And of course, this is going to be your instructions. Make sure you guys watch today's lesson on the video, fill out your guided notes in the white packet. If you need to email me, here's my email address. Keep in mind that you have 45 minutes of instructions every day. Your attendance is taken by you viewing the assignment, and your academic grade is given to you if you upload the assignment. And I actually updated your grades because every Monday your grades are updated. And so what I'm going to do is I'm going to post it out there for you as well. So just give me a second. The link that you guys need today is just going to be the Algebra 1 channel for your videos on the YouTube. You should have 5 videos on there. Hard copies are available to pick up. This is going to be our last week of full-time distance learning. I should see you guys coming back on January 19th, which is the Tuesday after Martin Luther MLK Day. I should just say that instead. Keep in mind that your schedule is from 8:30 till 9:15. You need to follow the schedule in mind. And I do take attendance right at 3 p.m. So make sure you guys complete everything and upload that. And so with that said, I'm just put 3:30 p.m. and it is due the day that it is assigned, and it is assigned for the 11th. Okay, so then I'm going to go ahead and click on assign. Okay, so now I'm going to go ahead and show you guys your grades. Let's do the section summary. And I want to do this so that your student number, and make sure it's for, no, that's not it. We want to do for algebra. And your grades are already posted for that first week. And so this semester, your grades are from 5 to 10 points. So just keep that in mind. So if you didn't bother doing anything, you'll just get a 5. So when you see like, oh, I got a 5, that means I did it. Maybe she just inserted it as a mistake. No, it's not a mistake. You guys get 5s. We start at 5s. And so if you take a look at this right here, this is your grade. And it only has 1 grade that's inserted into the assignment right now because it's just for week 1. And so if you get a 5, it means that you didn't check in with me, you didn't view any of the assignments, and you just simply kind of extended your vacation. You didn't really do anything. If you got a 6, it means that you did view some of the assignments, but you didn't upload any of the work back to me. If you got a 7 or 8 or 9, it means you did turn in at least 1 assignment. But if you got a 10 or 9 or 10 or a 9.5, it means that you turned in majority of your assignment, as in you uploaded it. And so I do have it. So just keep that in mind, you guys. So I'm going to go ahead and I'm going to paste this onto your assignment as well. So that way you're able to see this. So we're going to go back to MS Team. Here we go. And you should have your assignments already done. I'm just put Monday's grade check for week 1. And then scores are from 5 to 10 points. And this is what it generally means. If you get a 5 equals no check-in, a 6, 7, 8 means you viewed some assignments. And then if you have a 8, 9, that means you turned in some assignments. And then of course if you get a 10, that means you uploaded and turned in all assignments. So good job for those of you guys who did that. And here are your grades. All right, so if you click on this right here, you should be able to see your grades. I want to make sure you guys know exactly where you are. For those of you guys that have a 50 right here, that means you didn't check in with me at all. And there's a few of you guys who didn't bother doing that, and that's why you currently have an F. But this year, you guys have 5 to 10 points, and so just keep that in mind. But there are also a lot of you guys with A's because you turned in your assignments, and I appreciate that. And just keep on the good work and continue trekking forward for week 2, and you'll get another grade coming up at the end of this week. All right, so with that said, I'm gonna go ahead and turn this over back to today's lesson. Today we're going to talk about growth and decay, so just keep that in mind. And so some of the examples of exponential growth is like something that grows really, really fast. Like if you look at the x value right here, the x value is just going by increments of 1. But then if you look at the y value, it's growing kind of small in a decimal, but then it exponentially goes up in hundreds. And so in exponential growth, you can see that the x value gets bigger and the y value can get very, very large quickly. So some examples of exponential growth could be, I guess, the apocalypse and people turning into zombies. So if you watch The Walking Dead, you know, a lot of zombies are coming alive very, very quickly over the days, you know. So that could be a possible example of that. Example of exponential decay means that you are literally losing things very, very quickly. It's getting very, very small very quickly. Like for example, if you take a look at this right here, so that's something you can think about. Now, exponential growth equation always have like the x value as an exponent. We are so used to seeing that the x value as being part of the equation, like y equals mx plus b. That's a linear growth. Exponential growth is when the x is as an exponent, and that's what we've been talking about rules of exponents all this time as well. So just a quick little difference, a quick little comparison. Growth looks like this, decay looks like this. These are what the two equations look like. So just take a moment and soak that in. All right, so then with that said, let's take a look at today's guided notes. This is what it looks like for the first page. This is what it looks like for the second page. And if you have not grabbed the hard copies yet, you can go ahead and print this out, just the 2 pages for today. And I'm gonna go ahead and copy this so that way you guys have a copy of this as well, so you can print it out and I'll attach it to the assignment for today. Let's see, let's do a new one. I want to do this layout design a little bit differently. No, that's not it. How do I change? Okay, just give me 1 second here. Let's see what is going on. Let's close this one. Let's save this one as actually save as. Browse. Let's put this on the desktop. Okay, so then I'm going to delete this part right here, paste it right here. I'm going to do File, Save As, put this back in Algebra 1. spring 2020 for week 2, Monday. Algebra 1, semester 2, exponential growth and decay. And I'm just going to put guided notes. And I want to do this as a PDF. Oops, no, that's not a PDF. There we go. Save. All right, so let's go ahead and go back to MS Team to make sure you guys have that available. Reply, attach. Oops, let's go to that. All right, and here it is right here. And it is going to get attached once it's loaded. All right, perfect. So then when you click on it, you guys, click on this, and then you'll see that you have the PDF that you can go ahead and print out from at home if you just need the notes for Monday, week 2. And once it downloads, this is the first page, second page, and then your exit ticket is right here. All right, so with that said, let's continue on with today's stuff. Here is the breakdown for today. So go ahead and take a moment and read what we're going to be doing. You do need to have a calculator for today. All right, let's go ahead and get started with this. There are many examples of exponential growth and decay in everyday life, such as bacteria growth, radioactive decay. Population growth depends on size of the current population. The rate of the population growth can be predicting the size of the population at any given time. So the following graph of exponential growth and decay have the distinct shapes shown below. Well, this one's a growth because if you look at it, it's growing really quickly over a short period of time. This one is like saying this is the population, and then boom, something happens like the apocalypse or something, and the population is decreasing very quickly at a very short time. So before we get started, I have 3 questions for you that I want you guys to go ahead and reflect and then write down. Number 1 is, can you suggest any everyday examples of exponential growth or decay? Maybe come up with 2 or 3. Number 2, what can you say about the gradient of the graph shown in exponential decay? And when I say gradient, I'm talking about the slope, like the curve. And next, what can you say about the gradient graph shown of exponential growth, or vice versa? So pause the video and go ahead and answer the following 3 questions. All right, so blast into the past. When we go graphing lines, the first method we discussed this year was by plotting points, right? Like you get an X value, you plug it in, you get a Y value, you plot that 1 point. So the plotting point method consists of choosing an X value, and you're gonna plug those X values into the corresponding Y values, and then you're gonna graph a point for X and Y. And so we're gonna go ahead and do that as well, just for this example. So for the very first one, what you're going to do is you're going to notice that y equals 2x plus 4 is a linear function. And what you're going to do is you're going to take these values for the x, I'm going to plug it in right there into the equation. So here I have 2 times negative 2 plus 4, which is a negative 4 plus 4, which is a 0. So my first point is negative 2, 0. So negative 2, 0. First point right there. Next, I'm going to have 2 times negative 1 plus 4, which is a negative 2 plus 4, and that's a positive 2. So negative 1, 2. Next, I have 2 times 0 plus 4, which is 0 plus 4, and that's just 4. So 0, 4 is my third point. 2 times 1 plus 4 is a 2 plus 4, which is a 6. So my fourth point is a 1, 6. And then next, 2 times 2 is a 4. 4 plus 4 is going to give me an 8. So my last point is 2, 8. Now that I have these points here, I'm going to connect the dots, and I have a linear line. Okay, so this is a linear growth because it's just going by a straight line. It's just very steady and simple, and it has a positive slope. So this is just a steady growth of a linear function. All right. Next, what we're going to do is we're going to talk about what happens if you have exponential growth. And remember, the exponential growth, your x is not on the bottom with the equation, it's actually an exponent. Okay, so it's on top. So in this case, you're going to use your calculator. So you have 3 to the negative second power. And remember, we don't like negatives. So rules of exponents with negatives means that you have to bring it down. So you have 1 over 3 squared now. So it's now a positive. So what's 3 times 3? It's 1 over 9. And you have to put this into a calculation, which is going to be into a decimal, and that's 0.11. So my first point is -2, 0.11. So -2, 0.11 is going to be like literally right there, you guys. Very, very small. Okay, then I have 3 to the negative 1 power. So I have 1 over 3 to the positive 1 power because you have to bring that negative exponent down. So 1 over 3, plug it into your calculator, is going to give me 0.33. So negative 1.33. Getting a little bit bigger. Next, I have 0. Remember, one of the rules is anything to the 0 power is always, and you got it, it's going to be 1. So my next point is 0, 1. Continuing on, 3 to the 1 power is just going to be 3. So 1, 3. So notice how it's growing a little bit faster. And the last one is 3 squared. So that's 3 times 3, and that's 9. So my last point is at 2, 9. Now I'm going to have you guys take your pencil and connect the dots. And this right here is going to show you an exponential growth. And a good example of exponential growth is, for example, like bacteria growing, okay, because it grows and it doubles every single minute, for example. All right, so let's go on to the next part. Example 3. For example 3, I'm going to have you guys go ahead and try it on your own. So pause the video and give it a try. Okay, so then looking at this right here, your first point is -2.25. So -2.25 is right here. 2 to the negative 1 power, you bring that down to make it a positive 1. So 1/2, so it's going to be a 0.5. -1.5. 2 to the 0 power is 1, 0, 1. 2 to the 1 power is 2, so your fourth point is 1, 2. Then you have 2 squared, so that's going to be a 2 times 2, which is going to give you a 4. So your next point is 2, 4. And of course, your last one is 2 to the 3rd power, so that's 2 times 2 times 2, 3 times. And that's going to give you an 8. So your last point is 3, and you go up to 8. So your work should look something similar to mine. Connect your dots, and this is your graph. All right, let's take a look at example 4. With example 4, notice the difference. What do you see the difference as this versus the last one? The last 2 examples, you always had a number in the parenthesis that is either 1 or bigger. Okay, and that represents exponential growth. Okay, because we had a 2 and a 3, right? Now, if you have something that's smaller than a 1, like for example, 1 over 2, which is 0.5, that is not going to be a growth, that's an exponential decay. So my graph is going to look a little bit different. So let's see how different it's going to look. So 1/2 to the negative 2nd power is going to be 0.5 to the negative 2nd power, because another way of writing 1/2 is just 0.5. And so if I move that down, it's over 1 over 0.5 to the positive 2 power, which is just going to be 0.5 times 0.5. which is going to give me a 4. So at -2, it's going to give me a 4. I'll start right there. Next one is going to be 0.5 to the -1 power. And again, you bring it down the bar. You put a 1 on top. So 0.5 to the +1 power. So it's just 1 divided by 0.5. Grab your calculator, and what does that give you? That gives you a 2. So your next point is -1, 2. Third point, 0.5 to the 0 power is just going to give you a 1. So 0, 1. 0.5 to the 1 power is just 0.5. So 1, half. Be right there. And then we're going to have 0.5 to the 2nd power, which is going to be 0.5 times 0.5 twice. And that's 0.25. So my point is going to be at 2.25, which is me right there. And then lastly, 0.5 to the 3rd power is 0.5 times 0.5 times 0.5 3 times, which is going to give you a 0.125. So 3, 0.125. And if I take a look at my answers right here, I'm going to go ahead and connect the dots. And look how different this graph looks, okay? Because it is an exponential decay. So you're starting off with pretty high numbers up here, and then you're very quickly getting to very small numbers. So an example of this is like in case the world had an apocalypse and everybody is just, obliterated and being attacked by zombies. And that would be the population. So next what I want you guys to do is take a look at how are the graphs of y equals 2 to the x power and y equals 1 over 2 to the x power are related. So give me a sentence on comparing the two different equations. Okay, example 5. I want you guys to give this one a try on your own. So go ahead and pause it. All right, so your work for number 5 should look something similar to mine. And if you take a look at it, if you go ahead and connect the dots, this should be your exponential decay. And now that you've completed this, I want you guys to reflect on this and say, comparing these graphs to the first graph you created today, based on your observations, predict how the graph of y equals b to the x and y equals 1 over b to the x are related. And what point do all graphs of form y equal b to the x have in common? For this one, I would say that because it's y equals b to the x or y equals a to the x, these are all exponential growth. Now, similarly, if everything here is going to be in a form of a fraction, which means that it's smaller than 1, then all of these will be an exponential decay. All right, you guys, so with some additional practices, I would like you guys to go ahead and practice with these questions here. So you can pause the video and do some additional practice. And then I have a real world application right here that says, suppose as a New Year resolution, which we just had a new year, you decided to save your money in the following ways. Before the start of the year, you had 25 cents at a piggy bank. Each day, you would double the money in your piggy bank. So on January 1st, you would have 50 cents saved. Okay. Then on January 2, you will have $1, and then continuing on. So then without a calculator, go ahead and fill out this table, graph this right here on the grid, connect the dots, and how much would you have if you kept going until January 31st? So then looking at this right here for the 3rd, I'll have $2, double $4, $8, $16, $32. Now that's only on the 7th. So I want you to keep doing this until the 31st, okay? And then continue doing that. And then in addition to that, make sure you guys are graphing this as well. All right, you guys. So for your last part of this, your exit ticket is this. Following question, you have what surprised you today? What's the most important thing you learned today? What do you want to learn more about? When were you most creative today? What made you curious? Where were you at your best? Where should you start tomorrow? And what can you do? And what do you know? You could pick any 3 questions for your exit ticket. And then if you need some extra credit to go ahead and boost your grade a little bit, you can go ahead and work on this part right here. I know it's on the side. As always, stay safe and healthy, and I'll see you guys next time. Take care.